Hello, my name is Hasnain Niazi.
Hello, my name is Joe Wynn.
Hello, everyone. My name is Lloyd Wan.
Good morning, everybody. My name is Tommy Wynn.
Hello, my name is Musamu Desir, and we want to improve campus mobility using AI. So for a little introduction, imagine circling the parking garage or parking lot on campus over and over again right before class, watching as the minutes tick down and knowing that you're going to be late once you find a parking spot. Parking at UTD isn't just inconvenient, it's a daily frustration for hundreds of students and faculty. Our team set out to explore whether artificial intelligence could fix that problem. Specifically, we conducted a feasibility study on using AI computer vision technology to automatically detect open parking spots uh, and share that information in real time. The goal behind this project is simple: reduce the time it takes to find parking, ease campus traffic flow, and improve both safety and data efficiency. Today, we'll walk through our research, survey results, technical approach, challenges, and overall recommendations that we have to show how an AI-powered parking assistant could improve mobility across the UTD campus. Now that you know our goal, I'll hand things over to Tommy to explain the problem in more detail.
Thanks, Musa. To understand the scale of the issue, we surveyed UTD students about their daily parking experiences in October 2025. Nearly 40% of respondents rated their satisfaction 1 out of 5 stars, and more than half gave it 1 or 2 stars overall. Students mentioned long search times, limited spaces, and the stress of arriving late to class. UTD enrollment has continued to rise at an exceptional pace, but parking hasn't kept up. The current system lacks any real-time visibility, leaving drivers to rely on luck. Simply adding more parking spots will increase prices for closer spaces and increase student frustration with walking increasingly further. These findings confirm that congestion isn't just a perception problem, it's a measurable barrier to campus transportation efficiency. To show how we collected the data, I'll now pass it on to Joe to discuss our methodology. Thank you.
Great way to put it, Tommy. For our project, we wanted to really understand students' experiences and opinions directly. And in order to do that, we collected data using a Google Form survey that we distribute across several student group chats and in-person requests. The survey focused on key metrics such as overall satisfaction with the current parking, the level of frustration with availability, and interest in potential solutions, specifically the use of AI-based systems to help manage and predict parking. Now that we've uncovered how we gathered our data and what we focused on measuring, let's take a look at what we actually discovered. Um, Using the information from the survey, we have determined that there were three priorities that were continuously emphasized by the students, and is that they want real-time tracking of open spaces, predictive alerts for busy hours and peak times, and the integration with the current UTD app and its default navigation system. In other words, they want an intelligence assistant, not just another static map. They're looking for a system that can anticipate congestion and guide them proactively. And so in the survey, the 93% approval rate tells us that if UTD were to implement a reliable, privacy-safe solution, students will use it immediately. And to explain how the system could technically work, I'll hand things off to Hasnain to walk through the underlying technology.
Taking into consideration the student priorities explained by Joe, we can connect those priorities to the technologies that make them a reality. Traditional parking systems, such as your typical parking structure, rely on fixed sensors and manual monitoring, which have a high initial cost and require maintenance while malfunctioning on a daily basis. In contrast, AI computer vision uses existing security cameras to detect whether a space is occupied. The algorithm we studied, MaskRCNN, can identify cars in open spots with accuracy rates above 95% in real time. Because it is primarily software-based, it scales easily across multiple garages and reduces hardware costs. Fewer sensors means lower installation expenses and faster campus-wide adoption. It also means that we can go beyond tracking just parking structures to tracking and managing open lots. To elaborate upon these claims with evidence, I'll go over the research material. To To support our proposal for this parking system, we looked into several real-world academic and industry studies as well as relevant frameworks that demonstrate how effective this technology can be. First, a joint study by MIT and NVIDIA tests how AI and computer vision could identify open parking spaces using live camera feeds. Their systems achieved accuracy rates above 94% even in high-traffic areas, proving that this can operate in similar conditions to UTD's own parking lots. Next, we examined the PyVision framework, an open-source computer vision toolkit making it easier for developers to build AI models that recognize vehicles and empty spaces in real time. This framework shows that implementing an AI solution does not require starting from scratch. Existing tools already provide a strong foundation to begin. Finally, we reviewed several case studies highlighted in the Sapien blog, where universities and city systems have successfully adopted smart parking solutions. These examples showed measurable improvements, such as reduced congestion, faster space detection, and higher driver satisfaction. I will now pass on to Lo to discuss the ethical concerns and other challenges we had.
So now I'll talk about challenges and ethical concerns. Based on the information Hasnan shared, some of the biggest challenges with the system are privacy, reliability, and demand. Since AI parking relies on cameras, it could accidentally capture faces or license plates. And to prevent that, the system needs to use data encryption, anonymization, and university oversight to make sure it's handled responsibly. Reliability is another issue. Weak Wi-Fi or cell signal could cause lag during busy times, and heavy traffic might overload the system as well. So that's why we need testing, security checks, and system improvements before launching it across the campus. And even with these challenges, the data shows strong potential. And yes, now I'll pass it on to Tommy to talk about feasibility and next steps.
Appreciate it, Lloyd. We can conclude that UTD already has much of the infrastructure required for an AI vision parking system. We also believe that we can tackle the aforementioned challenges during development, continuing into post-development. We recommend a 3-step implementation plan. The first is a pilot test where we use existing cameras in parking structure 1 to evaluate real-time accuracy. Secondly, we plan on evaluating results by gathering student feedback, measure reliability, and refine detection models. Lastly, we want to expand campus adoption by integrating results into the UTD mobile app or web app for complete real-time visibility. This staged rollout keeps costs manageable and allows improvement before full adoption. To wrap everything together, I'll now pass it to Loy for our conclusion.
Thank you, Tommy. From what Tommy shared, our research showed that an AI-based parking assistant is both feasible and supported by students. The surveys we gathered show a clear demand for it, and studies prove that computer vision can actually perform better than regular parking sensors while being more cost-effective. If used properly, the system could cut down traffic, save time, and make parking safer on campus as well. And overall, the benefits outweigh the risk, and this project could be a real step toward a smarter and more efficient UTD. So next time, if you're circling the garage before the class, imagine your phone guiding you straight to an open spot. That's the kind of convenient AI powered parking could bring to you.